Hi, my name is Dr. Kobrowski and welcome to my lesson about naming alkynes according to IUPAC rules. Alkynes, of course, are compounds that have a carbon-carbon triple bond, and to name them we have to follow all the rules for naming alkanes with the following modifications. Rule 1. First, you have to identify the longest chain containing the triple bond, and then number the longest chain in a direction that gives the first carbon of the triple bond the smallest number. In this case, if I look at the green direction, the first carbon of the triple bond gets number 5. Whereas in the case of the red direction, the first carbon of the triple bond gets number 1. Since 1 is smaller than 5, the red direction is the correct direction for numbering. Rule number 2. To name the alkyne, start with the prefix corresponding to the number of carbon atoms in the longest chain, and then add YNE to the end. In this case, there are 6 carbon atoms in the longest chain. This corresponds to the prefix hex. To indicate that this is an alkyne, add the ending YNE to hex, and therefore this is a hexyne. However, the name is not complete yet. Here are the prefixes corresponding to the number of carbon atoms and then the resulting alkyne. 2 carbons is ethyne. Of course, ethyne is known commonly as acetylene. 3 is propyne, 4 is butyne, pentyne for 5, hexyne for 6, heptyne for 7, octyne for 8, nonyne for 9, and decyne for 10. Rule 3. To complete the name, the location of the triple bond must be indicated by placing the locant of the first carbon in the triple bond before the YNE ending. In this case, since the triple bond begins at carbon 1, we add 1 before YNE, and the name thus becomes hex 1-ine. Rule 4. If there is a substituent, the triple bond takes priority. What does that mean? Well, the longest chain has to be numbered to give the triple bond the smallest number, regardless of what substituents are present. So we don't look at the substituents for numbering, only the triple bond. In this case, the green direction gives the methyl substituent number 2. However, we don't look at that substituent. All we care about is the triple bond, and in this case, the triple bond begins at carbon number 4. Whereas in the red direction, the triple bond begins at carbon number 3. Therefore, the red direction is the correct direction, even though the methyl gets a much higher number, which is number 6. So the name of this molecule becomes 6-methyl-hept-3-ine. Rule 5. The longest chain must always include the triple bond even when a longer chain exists. So if we look at this molecule, looking at the green direction, we have 10 carbons in a row. However, the triple bond is not part of this chain. The red direction contains only 8 carbons. However, the triple bond is part of this chain. Therefore, the red direction is the correct direction for numbering, and it is being numbered in the direction to give the triple bond the smallest number. Therefore, the name becomes 3-butyl-oct-1-ine. Reminder: don't forget to number through the triple bond. This is one of the rules. You should always number through the triple bond. In the case of this cyclic alkyne, it is easy to forget this rule and go along the red direction to give the triple bond the smallest number possible and the substituent methyl also the smallest number possible, which is number 2. However, this is an incorrect numbering because you're not going through the triple bond. The correct numbering would be according to the green direction, which is through the triple bond. Now the methyl substituent gets number 3, not number 2. And therefore the name of this alkyne would be 3-methyl-cycloundecyne. And as the name shows, I didn't place the 1 before the YNE because it will be assumed that it is number 1 if there are no groups of higher priority. And that's all there is to it. If you learned alkenes, you will notice that naming alkynes is basically the same as naming alkenes. We follow all the rules of the alkene nomenclature. The only difference is alkynes don't have stereochemistry, which makes it actually even easier than alkenes. Okay, enjoy.